Hello students. So last class we already studied about spherical mirror, laws of reflection and how image form with respect to a spherical mirror and what are the condition of incident rays and reflected rays in case of spherical mirror and the types of spherical mirror. Today we are going to discuss another phenomena in ray optics, that is refraction of light. So what is refraction of light? So refraction of light means, in last class we already studied, if there is a surface on which light incident, some of the incident light gets back to the same medium and some part of the incident light transmit to the other medium. If this is medium 1 and this is medium 2, then some part of the incident light return back to the same medium. This phenomenon is known as reflection. We already studied about it. And some part of the light transmit to the medium 2. This phenomena is known as refraction. So today we are going to discuss about this phenomena. When light transmit from one medium to other medium, that phenomena is known as what? Refraction of light. Okay, so what is refraction of light? It is the phenomena by virtue of which light travels from one medium to another medium. Okay, the phenomena by virtue of which light travels from one medium to another medium, due to which its path, velocity and wavelength changes. Okay, so the phenomena by virtue of which light travels from one medium to another medium, due to which its path, velocity and wavelength changes, that phenomena is known as what? Refraction of light. Okay, so now if here is a boundary which separate two medium, this is medium 2 and this is medium 1, and this is the perpendicular or normal at this boundary. So if light comes from medium 1 and it makes an angle I with the normal, let the normal be N, O, N dash, and this is the incident ray, and after refraction through this surface it transmit to medium 2. So after refraction let it move along O, let the initial stage be MO, and after refraction through the medium 2 it travels along OP direction. Clear? So this ray is known as refracted ray. Okay, this is known as incident ray and the OP is known as refracted ray. If medium 1 is denser or rarer and medium 2 is denser, then the light after refraction bend towards the normal. That means if this angle by the refracted ray made with the normal ON dash be R, then if light travels from rarer medium to denser medium. Then after refraction, the refracted ray bend towards normal. So in this case, if this is rarer medium, medium 1 and medium 2 is denser medium, that means as light travel from rarer to denser medium, so after refraction the refracted ray bend towards normal. So for this case the angle of incidence is greater than this angle R is known as refracted angle. Okay, so what will be the deviation of light? Initially the light travels along this direction if there is no surface. If this surface is absent, the ray will travel along this direction. Due to this refracted surface which separate these two medium, the ray get bent to and pass along OP direction. So this angle is the deviation, delta. So what is angle of deviation? Delta equal to I angle minus R angle. Clear? This is the case only when light travel from rarer to denser medium. If so, here we also can write if V1 and lambda 1 be the velocity and wavelength of light in medium 1, that is rarer medium, and V2 lambda 2 be the velocity and wavelength of light in medium 2, that is denser, then V1 is greater than V2 and lambda 1 is greater than lambda 2. Clear? So when the light travels from rarer medium to denser medium, if in rarer medium its velocity and wavelength is V1 and lambda 1, and in denser medium its velocity and wavelength are V2 and lambda 2, then when light travels from rarer medium 1 to medium 2, that means the light travels from rarer to denser medium, so its velocity decreases and wavelength also decreases. Clear? So V1 is less than V2 and lambda 1, sorry, V1 is greater than V2 and lambda 1 is greater than lambda 2, where V1 is the velocity in rarer medium and V2 is the velocity in denser medium, and lambda 1 is the wavelength in rarer medium and lambda 2 is the wavelength in denser medium. Clear? Similarly, if light travels from denser to rarer medium, so if there is a surface which separates two medium, this is medium 1 and this is medium 2. Now medium 1 is denser and medium 2 is rarer. Okay, and this is the normal and light incident along this direction by making an angle I. This is the angle of incidence. So as now light travel from denser to rarer medium, so after refraction through this surface, the light ray bend away from the normal. Let this is the normal N, O, N dash. So this is the incident ray which is comes along this direction, let this M, O. After refraction, the incident ray becomes refracted ray and the refracted ray bend away from normal, so it will goes like this. Clear? So now this is OP, this is known as what? Refracted ray. So if this angle is I, this angle will be R. So here we can write, when light travels from denser to rarer medium, it bends away from normal. Okay, you have to remember this point. So this implies if it bends away from normal, so here angle of refraction is greater than angle of incidence. Here R is greater than I. So what will be the deviation? The deviation angle will be R minus I. Clear? This angle is I. So this is the deviation. So this angle will be how much? R minus I. Clear? So here angle of deviation will be R minus I. Similarly, if V1 lambda 1 are velocity and wavelength in medium 1 and V2 lambda 2 are velocity and wavelength in medium 2, where medium 1 is denser and medium 2 is rarer. So as light travel from denser to rarer medium, so here we can write V1 is less than V2 and lambda 1 is less than lambda 2. Clear? So when light travels from denser to rarer medium, its velocity increases and wavelength also increases. Clear? So this is about refraction. So refraction is the phenomena due to which light travel from one medium to another medium. Clear? If the light travels from denser to rarer medium, the angle of incidence is less than angle of refraction. That means the light after refraction in the rarer medium bend away from the normal, and its velocity and wavelength changes, and when it travel from denser to rarer medium, the velocity of light increase and also its wavelength increases. Similarly, when light travels from rarer to denser medium, its velocity decreases and wavelength also decreases. Clear? So during refraction, the light changes its path, its velocity and its wavelength, and according to the direction of propagation of light, either it is travel from rarer to denser or denser to rarer, accordingly the velocity and wavelength increase or decreases. Clear? So now we have to study about what is refractive index. So before that you have to remember one point. During refraction, son of light, its velocity, path, wavelength changes, but its frequency remains constant. Okay, because frequency is the property of source, not medium. Okay, you have to remember this point. During refraction of light, velocity changes, path changes, wavelength changes, but frequency remain constant. Frequency does not change because frequency is the property of the source which produces the light, not the medium. Clear? So during refraction, medium changes, that's why wavelength, path and velocity changes, but frequency never changes because frequency is the property of the source. So until the source remain constant, the frequency of the light remain constant. Clear? So next, what is refractive index? So from this we can write a relation that as light is a electromagnetic wave, so we can write the velocity of light equal to lambda into f. We already studied about it in the wave chapter in your first year syllabus, that is, as light is a electromagnetic wave, so its velocity will be lambda into f. So this implies v is equal to some constant into lambda, as here lambda equal to wavelength, f equal to frequency, and v equal to speed of light. This is frequency of light, this is wavelength of light. So as frequency remain constant for a given light, so v equal to constant into lambda, so this implies that v is directly proportional to lambda because frequency remain constant. So during refraction frequency remain constant, so v is directly proportional to lambda, or this implies that v1 by v2 will be equal to lambda 1 by lambda 2. Clear? So when velocity will increase, wavelength will increase. When velocity will decrease, wavelength will decrease, because frequency of the light ray remain constant during refraction, because frequency is the property of what? Source. Clear? So you have to remember the relation between speed and wavelength. So speed and wavelength both are directly proportional to each other, because v is equal to f lambda, so f remain constant, so v is directly proportional to wavelength. So speed of light is directly proportional to wavelength. When velocity increases, the wavelength increases. Clear? So next we have to study what is refractive index. It is basically denoted by mu. So what is refractive index? So refractive index is a constant of a medium which determines the speed of light within it. Okay, so the refractive index is the property of a medium which determines the speed of light in that medium. Clear? So as light is a electromagnetic wave, that means light produced due to both electric and magnetic field. Clear? So it's travel in any medium because it is independent of the medium, but depending upon different types of medium, the speed of the light changes. So that property of the medium which determines the speed of light is known as what? Refractive index of the medium. So this refractive index of the medium can be given as if in space we can write the speed of light, c is equal to how much? 3 into 10 to the power 8 meter per second. So this can be written as 1 by under root mu naught epsilon naught. What is mu naught? Permeability of free space, and epsilon naught permittivity of free space. This value is equal to 4 pi into 10 to the minus 7, and its value equal to 8.854 into 10 to the minus 12. So by using this we will get the speed of light in free space will be this much. So what is the speed of light in any medium? So this can be written as 1 by under root mu naught mu r into epsilon naught epsilon r. What is mu naught? Mu naught is the permeability of free space. What is epsilon naught? Epsilon is the permittivity of free space. What is mu r? Mu r is the here mu r equal to relative permeability. of the medium, and epsilon r is the relative permittivity of the medium. So this can be written as the speed of light in any medium equal to 1 by root over of mu naught epsilon naught into 1 by root over of mu r epsilon r. So this can be written as what is mu 1 by mu naught epsilon naught. This is the speed of light in free space. So speed of light in any medium equal to speed of light in free space divided by root over of mu r epsilon r. Clear? So this mu under root mu r epsilon r, this term is known as mu, the refractive index of the medium. Clear? So from this we can write the refractive index equal to how much? What is refractive index? Root over of mu r epsilon r. So refractive index of the medium mu m, which is equal to under root of mu r epsilon r equal to speed of light in free space divided by speed of light in the given medium. Clear? Okay. So what is refractive index of a medium? It is the ratio of speed of light in free space to that of speed of light in that given medium. Clear? So refractive index of any medium is defined as the ratio of speed of light in free space to that of speed of light in the given medium. Okay. Whose value equal to under root of mu r epsilon r. What is mu r? Relative permeability of the given medium, and epsilon r is the relative permittivity of that given medium. So this mu m or refractive index of any medium will be speed of light in free space divided by speed of light in the given medium. Okay. Okay. So this is known as the refractive index. So if in a given medium the speed of light is c1, so this can be written as the speed of light in free space divided by refractive index of the medium, that is mu1. Similarly, if the speed of light is given in a medium, that is c2, so this can be written as speed of light in free space divided by refractive index of that medium mu2. So from this relation we can write the speed of light c1 is equal to some constant divided by mu1, as speed of light in free space is constant, that is 3 into 10 to the power 8 meter per second. Similarly, the speed of light in any medium 2, that is c2, will be written as some constant divided by refractive index of that medium mu2. So from this you can write the speed of light in any medium is inversely proportional to the refractive index of that medium. Clear? So if the refractive index of the medium is more, the speed of light will be less. If the refractive index of the medium is less, the speed of light will be more. So from this relation we can write c1 by c2 equal to mu2 by mu1, where c1 equal to speed of light in medium 1, c2 equal to speed of light in medium 2, and mu1 equal to refractive index of medium 1 and mu2 equal to refractive index of medium 2. So you have to remember this relation, that speed of light of in any medium is inversely proportional to a refractive index of that medium. Clear? So previously we already established an relation that the speed of light, which is let be v or c, the speed of light is directly proportional to its wavelength because frequency remain constant, and now we establish a relation that speed of light is inversely proportional to the refractive index Clear? Where c equal to speed of light in any medium is directly proportional to wavelength of that medium, and speed of light in any medium is inversely proportional to refractive index of that medium. So from this relation we can write speed of light in medium 1 divided by speed of light in medium 2 will be equal to wavelength of light in medium 1 divided by wavelength of light in medium 2, which will be equal to refractive index of medium 2 by refractive index of medium 1. Or simply C1 by C2 can be written as by the general notation V1, that is speed of light in one medium, divided by V2, that is speed of light in medium 2, which can be written as medium wavelength in medium 1 by wavelength in medium 2, or this can also be written as refractive index of medium 2 divided by refractive index of medium 1. You have to remember this relation, it's a important relation, how speed of light, wavelength and refractive index of the medium are related. Clear? So refractive index is a unit and dimensionless constant. Because what is refractive index? Refractive index is the ratio of speed of light in free space to that of speed of light in the given medium. So it's a perfect ratio. So refractive index, it's a unitless and dimensionless constant. Because refractive index of the medium equal to speed of light in free space by speed of light in the given medium. So this is velocity, this is velocity, so both will get cancelled. So it's a unitless and dimensionless constant. Clear? Next, what is relative refractive index? So relative refractive index, it is the refractive index when with respect to two medium. That means when light travel from one medium to another medium, not specifically one medium will be free space. Okay, so in any two medium, when light travels from one medium to other medium, then the ratio of both refractive index of both the medium will give the relative refractive index. That means if light travels from medium 1 to medium 2, where refractive index of medium 1 is mu1 and refractive index of medium 2 is mu2. So the relative refractive index mu_r will be defined as mu2 by mu1, where light travels to 2 from 1. That means it can be noted as like this: if light travels from medium 1 to 2, light travels from medium 1 to 2, so the relative refractive index will be mu2 by mu1. So you have to remember this: the relative refractive index between two medium will be defined as the refractive index of the medium to which light is going divided by to the refractive index of the medium from which light is coming. So here, if light traveling from medium 1 to medium 2, the relative refractive index of both the medium will be mu2 by mu1. Similarly, if light travels from mu2 to mu1, that means from medium 2 to medium 1, so this can be written as light travels from mu2 to mu1, so its relative refractiveness will be mu1 divided by mu2. Clear? So the relative refractive index between any two medium will define as what? The ratio of refractive index of the medium to which light is going divided by the refractive index of the medium from which light is coming. So if medium light travel from 1 to 2, the relative refractive index will be mu2 by mu1. If light travels from 2 to 1, the refractive index will be relative refractive index of both the medium will be mu1 by mu2. Clear? So this is known as what? Relative refractive index, okay, of any two given medium. So when absolute refractive index is specifically the refractive index with respect to free space, but in case of relative refractive index, the both mediums are different. It not necessarily one of them will be free space. Clear? So next we have to study laws of refraction. So what is laws of refraction? Similarly, the first laws of refraction states that the incident ray, refracted ray and normal at point of incidence all lies on a same plane. Clear? The incident ray, laws of refraction. The first law will state that the incident ray refracted ray and normal at point of incidence all lies on same plane. Okay, that means if this is the surface which separate two medium 1 and 2, let this is refractive index mu1 and mu2, and this is the normal, and light travels from medium 1 to medium 2. This is incident ray. Here mu1 is greater than mu2. That means medium 1 is denser and medium 2 is rarer. So after refraction, light will bend away from normal. So it will goes like this. Clear? So this angle is I, this angle is R. So the normal NO N dash, the incident ray QO and the refracted ray OP all lie in a same plane. Clear? This is known as the first law of refraction. Then what is second law of refraction? That is known as Snell's law. It states that the ratio of sine of incidence angle and sine of refracted angle is a constant which is equal to the relative refractive index of the medium. Okay, so it states that the ratio of sine of incidence angle and sine of refracted angle is a constant which is equal to the relative refractive index of the medium. That means if the light travels like this from this medium to this medium, this is I, this angle is R. Okay, this is medium 1 having refractive index mu1 and medium 2 having refractive index mu2. So for this particular case, according to Snell's law, we can write sine I divided by sine R is equal to the relative refractive index of this medium. So here light travels from medium 1 to medium 2. So the relative refractive index will be medium light traveling from 1 to 2. So sine I by sine R equal to mu 1 to 2, or this can be written as mu 2 by mu 1. Because relative refractive index of two medium can be written as the refractive index of the medium to which light is going divided by the refractive index of the medium from which light is coming. So here light travels from medium 1 having refractive index mu1 to medium 2 having refractive index mu2. So it will be sine I by sine R, which will relative refractive index from 1 to 2, which will be written as mu2 by mu1. And from this relation we can write mu1 sine I equal to mu2 sine R. You have to remember this relation. What is mu1? Mu1 is the refractive index of the medium from which light is coming, and mu2 is the refractive index of the medium to which light is going. And sine I is the angle of incidence, and R is the angle of refraction. So this is known as what? This is known as Snell's law. Okay. Okay, so this is known as Snell's law. So from this law we can write if light travels from medium 1 having refractive index mu1 to medium 2 having refractive index mu2, then you can write sin I by sin R equal to mu 1 to 2, which is equal to mu 2 by mu 1, or this can be written as mu 2 by mu 1 can also be written as lambda 1 by lambda 2, or this can also be written as V1 by V2. So in simple we can write sin I by sin R is equal to mu 2 by mu 1, which is equal to lambda 1 by lambda 2, which is equal to V1 by V2, where mu 1, lambda 1, V1 are refractive index, speed of wavelength of light and speed of light in medium 1, and mu 2, lambda 2, V2 are refractive index, wavelength and speed of light in medium 2, and I is the angle of incidence and R is the angle of refraction. And here what is mu 2 and mu 1? Mu 2 is the refractive index of the medium to which light is going, and mu1 is the refractive index of the medium from which light is coming, and combining this relation we can write mu1 sin I will be equal to mu2 sin R. These relations are important, you have to remember this. Clear? So the important is mu2 is always the refractive index of the medium to which light is going, and mu1 is the refractive index of the medium from which light is coming. Okay, so next we are going to discuss about what is principle of reversibility. That means, what is principle of reversibility? The light can retrace its path after a number of refraction and reflection. Okay, for example, here is a medium or a surface which separate two medium. This is medium 1 having refractive index mu1, and this is medium 2 having refractive index mu2. Okay, so here mu1 is greater than mu2, so medium 1 is denser and medium 2 is rarer. So when a medium will be denser medium means high refractive index. Okay, rarer medium means low refractive index. Okay, so when the refractive index is more or high, the medium is known as denser medium. When the refractive index is low, the medium is known as rare medium. So as here mu1 is greater than mu2, so the refractive index of medium 1 is more than that of 2. So medium 1 is considered as denser medium and medium 2 is considered as rarer medium. So now a light is incident which is coming from medium 1 to medium 2 by making an angle I. So as this is the normal NO, N dash. So as light coming from, let SO be the incident light which is coming from medium 1 to medium 2, which is makes an angle I at the point of incidence O. So as the light coming from medium 1 to medium 2, that means from denser to rarer medium, because mu1 is greater than mu2. So after refraction it will bend away from normal because it comes from denser to rarer medium. So after refraction it will bend away from normal. So it will goes like this along SOT. So at the path of the refracted ray, if this angle is r, there is a plane mirror on which the refracted ray strikes it normally. Let m dash be a plane mirror on which the incident ray, the refracted ray OT incidents normally. As the ray incidents normally, due to reflection, it will again retrace its path. So the reflected ray TO goes along the same path as that of OT, and at point of O again it will go through a refraction, and now the ray will goes from mu2 to mu1. So the angle of R or refracted angle for the first case will now become the incidence angle, and the incidence angle for the first case will now become the refracted angle. Clear? So if I am applying the Snell's law for the first condition, when light travels from SOT direction, I can write sin I by sin R. This is the angle of incidence for when light travels from SOT direction, will be equal to light travels from mu1 to mu2. Clear? Let it be equation 1. Now when light will retrace its path after the reflection from the plane mirror, I can write the path will be TOS. So for TOS path, R will be the incidence angle, so I can write sin R by the refracted angle will be sin I, equal to, now light travels from second medium to first medium, mu2 to mu1. This will be equation 2. Clear? So multiplying these two equations, I can write, by multiplying equation 1 and 2, I can write sin I divided by sin R into sin R divided by sin I equal to how much? Mu1 to 2, mu1 to 2 into mu2 to 1. So this will get cancelled. So I can write mu1 to 2 into mu2 to 1 equal to 1, or from this you can write mu1 to 2 will be 1 by mu2 to 1. Clear? You have to remember this relation, that mu1 to 2 is equal to mu2 by mu1, which is equal to 1 divided by mu2 to 1, which is equal to mu1 by 1 divided by mu1 by mu2. Clear? So this is known as what? Principle of reversibility. Clear? So due to a number of refraction and reflection, the ray can retrace its path. That is known as principle of reversibility. Clear? Okay, so this is all about today's lecture. Next class we are going to discuss about refraction through a glass slab and further details. Okay, thank you.